Hello and welcome to the Borde and Round's Kitchen Chemistry. Today we're going to show you a simple method of carrying out paper chromatography inside your own kitchen.
Now this is for Year 9 students, this one, because you're just about to do your chemical analysis topic, and in there is the chromatography lesson. So hopefully you're doing a chromatography lesson. We want to show you something you can do that's practical and fun.
There we go. First thing you'll need is some sort of protective layer for your table that you're going to do it on. So a placemat, a chopping board, a plate would work even better. Okay, and also what you'll need is a piece of kitchen towel. Simple piece of kitchen towel. There we are. All we have to do.
You'll need some ink as well. So we've just got some board markers here, but if you've got any felt tips or anything like that at home, they will work just as well.
So this method is really simple. Instead of using a ruler and a pencil line as you've done in Year 8, this method is just drawing circles onto a piece of kitchen roll, just like that, with your ink, and we've got pipettes here and a mug full of water, so you can use a mug for your water. Taking a pipette, if you've got any cowpole handy, the cowpole usually comes with a syringe, you could use the syringe from that to drop your water into the centre of your paper. Just nicely like that. Keep soaking it so you get an even spread. Try to keep the paper as flat as you possibly can. And what you would see to start to happen is the ink starting to spread through the paper, and you can see the different colours that have been released as the ink has travelled through the mobile phase.
So hopefully what you've actually looked at before you've looked at this video is the actual theory, and that there's two phases in chromatography. We've got the stationary and the mobile phase. So the stationary phase here is represented with your kitchen roll, and the mobile phase is the movement of the water, which is the solvent.
Slightly better one done there by Mr. Round. Excellent.
We then also want to show you how you can analyse your what's called chromatograms. So these are now chromatograms, and they're what you end up with after you've done your paper chromatography.
You should have seen this formula already, which is your RF value, which is the distance of the solute movement divided by the distance of the solvent. Okay, so to calculate the RF value, you take your chromatogram and you choose the midpoint of one of your colours. So I am going to go for a purple colour here, which the midpoint seems to have moved 3 millimetres. 3 millimetres, so distance of solute equals 3 millimetres. There is lots. It's lovely, that one. I like that one. And then I'm going to now measure how far the actual solvent has moved. And when the solvent here is water, you can see that actually it's moved quite a distance. Let's have a look. And obviously I've measured in millimetres for my solute, so I'm going to measure again in millimetres for my solvent. And you're just measuring from the point that you drew the line from, the circle from. And this one is 26 millimetres for the distance that the solvent has moved. So solvent movement is 26 millimetres, or 2.6 centimetres. Mr. Round is now going to do our calculation.
So it is distance of solute, which is the ink, and that was 3, divided by distance of solvent, which was the water, and that's 26. 3 divided by 26 equals 0.115.
Rounded to 2 decimal places.
2 significant figures.
2 significant figures is 0.12.
0.12. Now an RF value must always be less than 1 as is. If it's more than 1, it probably means you've done the calculation the wrong way around. So you just need to check that one.
Now, you can make some awesome, pretty colours with this. Now, you might actually